Thank you for coming at this short course. Right. I would like to sound check. Please write in the chat box whether you can hear my voice clearly or not. Please let me know. Thank you. Attachment is not allowed. Okay. Wait. I want to share with you the slides. What's that? EAK FYP. Here's the slide. Yeah. Okay, I have sent the slide to you in the WhatsApp group. I haven't made changes to the dates. I'm truly sorry, I forgot about it. But I believe the content is the same, so don't worry. Now, shall we start? First of all, I would like to thank again for you to attend this class. Okay. If you guys has any questions, any doubt, any thoughts that you would like to share, or wanted me to explain it much clearer, please let me know. Okay, don't worry, just chill. All right. Okay. The lights is not that good for me here, but it's okay. Don't worry about the lights. So I would like to share the screen. Okay. The lights is not that good, but I believe it's okay. Don't worry about it. Now, again, if you have any questions, if you have anything that you would like to say, perhaps raise your hand. Not literally, of course, raise your hand using this, what we call this, the WebEx. Okay. I want to look one more thing, the chat box. Okay. So here is the chat box. All right. Now, here, today, I mean tonight, I want to explain more like sharing with you on the very fundamental understandings of GIS. Of course, GIS stands for Geographical Information System. This GIS is easily understood with geographical and computer. Okay, geographical and computer. Anything that you deal with GIS is actually with the help of computer. So to cut short, your computer basically need to be at least moderate or not too powerful. It's okay to be moderate but up to date. Okay, it is not like last, I don't know, last 5 years perhaps, but it's all depends on what you wanted to process. Okay, now here is the by book definition. Geographical or geographic information system is a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying spatial data. Well, it doesn't sound much, isn't it? It doesn't sound that this is something big, because basically your smartphone are now capable of doing these things, isn't it? Your phone definitely can do some capturing, can capture sound, it can capture images, right? It can stores the image, it can stores anything that you wanted to keep in your gallery, for example. It can checking, it can check anything, any informations that you would like to seek, right? It can integrate, right? It can integrate with um, uh, GPS sensors, for example. It can integrate with the your, what we call this, the headphones. It can integrate with Bluetooth. It can connect with the TV, for example. It can manipulate data. Let's say you are editing your image, okay, you are applying filters. That is manipulating. Analyzing, okay. When it starts with analyzing, is a bit uh, different, okay. And of course, displaying. Every smartphones nowadays can at least do some display, right? So the core difference between your smartphone with the GIS computer system is perhaps mostly on analyzing, okay. But if I said it is the capturing, storing, checking of just data, yes, your phone can do such things. But now we are talking about spatial data, not spatial, spatial data. Here, the spatial data is um, something, no, spatial data is a data that can be positioned on Earth, as we can say, on Earth. Earth is so difficult to explain that it requires a lot of mathematical algorithms in order for us to understand it. So one of the algorithms or the system that has been created is known as the GNSS system. Basically, it is a positioning system. Okay, so it is some sort of fishing net or fish net. Okay, if you take a fish net, I'm sorry, and then you wrap it on a ball. So the grid that is formed on the ball is the GNSS system. So spatial data integrates with the GNSS system makes the data contain coordinates, makes the data contain something that we can understand where it is it really located on Earth. Okay, all right. Again, if you don't understand, please let me know. I try to be not too specific. I try to relate to our daily activities or daily stuff that we has all around us. Okay, so please let me know if you don't understand. Now the input. Of course, GIS will receive this spatial data, a data that contain at least coordinates. Okay, and then we will do the processes, analysis, and data visualization, and the output will be new data and maps. New data and maps. Okay, so basically GIS will not has its own data. You are the one that need to capture the data, whether you wanted to do flood mapping, then you need to capture rainfall data at least. Okay, if you wanted to do water quality, you need to go to the site and capture, collect some water samples and do the lab analysis. Because GIS is just a tool. It will not give you its own data. Right. Next, some theoretical overview. GIS recreates the real world spatial data. From the real world, we wanted basically GIS turns it into a digital form. And then this spatial data will be digitized into a theme data layers. Theme data layers. For example, the locations of commercial auto car dealers, for example. Okay, auto car dealers means auto is car lah, car dealers lah. Location of car shop or car dealers all around Limbung Tebal, for example. Okay, that is one theme of data, and it will be a single layers in GIS. Next, perhaps you want some boundaries. Okay, we live in this tri-state area. Nimbung Tebal is close to where Nimbung Tebal is Penang, close to Kedah, Bandar Baharu, within 5 minutes. And then it is also close to Perak, Parit Bunta. Okay, so you want to find the locations of the car dealers together with the information of the tri-state boundaries. Okay, there are much more here, but I just give you some idea to think. And then this data is assembled in any combinations. It's up to you whether you wanted to focus on water quality. You need to assemble in a way that it highlighted the rivers, for example. It highlights the rivers for water quality. For flood, it highlights the residential area so that we can count how many houses that are affected by the flood. Okay, and then we overlay everything, every layers to do the analysis. So this is the theoretical overview of a GIS. Now the software. There are, of course, multiple type of software available. It can be using just the web browser. Okay, we call it as geo browser. There are also web-based uh, that provide you some quick analysis, and there is another one known as the desktop. Okay, the desktop here is the one that we are going to learn. Now, the geo browser, for example, the one that gives you quick, um, yes, just information. You cannot really do analysis. Okay, like Google Maps, you wanted to look for your friends' houses, your new girlfriends, your new boyfriends, for example. You can look through Google Maps. Okay, you insert the address and we will display it for you. It literally doesn't do any analysis. It's just query. Okay. Next is the web-based software, as you can see. But this one is not too specific. It is not uh, really usable for deep research. Okay, because it provides very limited tools like ArcGIS Online, Mapbox, or Google My Maps. Google My Maps is totally free for you to use. Okay, you can check it out. It provides you slightly more functions as compared to Google Maps. Okay, and the data is downloadable, of course. Yeah, the most powerful is the desktop where we install it into the laptop. Uh, the most used software is ArcGIS and Quantum GIS. But of course, ArcGIS is expensive. Therefore, we choose Quantum GIS. There are pros and cons, of course, between these two. But it's up to you and what do you want, what analysis that you wanted to do. Now, the question is, which software should I use, right? Okay, some of you did use ArcGIS, already use it. Well done. But if you want to discuss about it, perhaps you need to give me some time because currently I'm focusing on Quantum GIS. But it's okay. I have used ArcGIS for years. Yes, since my degree. Now, Quantum GIS is free to use. Okay, but of course there are pros and cons for both of these. First, ArcGIS is a single roof software. I mean, it is developed by Esri, ESRI here. Therefore, it doesn't allow too much modifications by the researchers. Okay, it doesn't allow any open source tools to be used in ArcGIS software. It limits so much so that only what was provided is the one that you can use mostly. Okay. Now, how about Quantum GIS? Quantum GIS is free and open source tools. That means it is an organization that developed this, but all the algorithms were donated by experts. Okay, so the organizations also comprises of many experts, of course. So they are checking all the algorithms given. There are a lot of free algorithms, free to be used, free to download. Okay, but the problem is some algorithm is too specific to some research uh, idea. Okay, so the results will be varied. The problem is in terms of results. But for the typical analysis, the quantum GIS has reached to at a researchable state, as you can say, a researchable state. It is not being rejected by the researchers worldwide. So it's getting better. Quantum GIS is getting better. That's why I'm starting to learn quantum GIS too. So as for this, training, we will be using quantum GIS. No worries, it's good. Next is the GIS applications. Okay, where to apply? First thing first, before we discuss on that, let's take a look at some of the data that it can provide. Okay, this GIS is applied in various field of study, as you can say. Okay, recently, just this weekend, I have spent 3 days to collect thermal data of building's roof. Okay, flat roof. So this thermal data can be processed in GIS in order to obtain some information regarding temperature of that particular roof. But it is actually much more than that. Okay, it can go into, some of you doing flood, yes. It can go into water quality, landslide mapping, geological mapping, anything you want to find natural resources. For example, gold, you want to look for golds, you can do this analysis using GIS as long as you have the data. Okay, what else? You can do like during my degree, I developed simple software to navigate the shoppers inside a shopping mall. Literally, yeah. Sorry. The shoppers just need to insert the items that they wanted to do the shopping, and then select the shopping mall that they wanted to go, and the software will provide um, the navigation to that particular item that they are looking for. Yeah, even that still apply the concept of GIS. Now here in this image is what known as remote sensing. Okay, this can give you the image that you able to see from the free to use Google Earth. Sorry, something happened. Right. So some of the sensors that is provided for free are Landsat 9 here. Landsat series, as you can see, there are 1 until 9. Recently is 9 series. Is getting much more powerful. It gives you high resolution data. Okay, and then the most powerful nowadays are Worldview 3 here. It can provide you up to 0.6 meters. There are one more I have recently read, just recently, last week, if I'm not mistaken. A new one, 0.4 meter, 0.4 meters. That means if you are hiding, uh, not hiding lah. If you are laying down on the ground, okay, Landsat, I mean that these satellites can actually observe you. Okay, it can see you individually, a person laying down on the ground, right, from hundreds of kilometers high in the outer space. Uh, these are the sensors. It's huge. This satellite is huge. Now, um, Sentinel-1 is one of the competitor for Landsat. Okay, in giving you free data. Okay, Landsat give you free data, but the resolution is limited to 30 meters resolution. But Sentinel-1 here give you 10 meters resolution. That is good. Okay, for free data, that is very good. But if you want more in terms of resolution, of course you can purchase it. Okay, as shown in the span of this image here, perhaps it costs you around 50,000 ringgit per image. Okay, next, there are cheaper options, of course. By spending 50,000 ringgit, you can get a single image from the satellites, or you can take that 50,000 ringgit and purchase drone. Okay, drone nowadays are getting much more cheaper than to do the mapping, but the problem is the technology is quickly developed. Means your instruments, your types of drones that you bought might be go out of date quite quickly. Okay, perhaps in 5 years time, you cannot use your model anymore. Okay, you have to purchase a new one. That is the uh, the the downside of having a commercial drone. Of course, if you can develop your own drone and using third-party software, for example, you can use it forever. I believe so. Okay, so there are here one of the biggest DJI drone. Uh, I'm sorry. This costs you around 250,000 ringgit. Okay, but it gives you superb data, types of data. It can literally scan the entire Earth. Okay, and the entire area. So yeah, it costs you 250,000. You can buy a house with this drone price. The Phantom has already cannot be used for mapping, but the system is the system is getting cheaper. You can now using DJI Mavic. Okay, it costs you around 18,000 ringgit, and then you can use the entire systems lah. Next is the fixed wing, not the just quadcopter. There are 4 blades here, quadcopter, like a helicopter. This one is the fixed wing drone. The fixed wing drone can cover a much bigger area because of it can glide. So when it can glide, it saves a lot of battery power. Okay, that's why it can cover a much bigger area. Similarly, here is the last one. The bottom one is the hybrid drone. It can take off on a point, and it can landing without any railway uh what we call that, anything. Okay, it can vertical landing. It can do vertical landing without any needs of road, for example. Okay, airways, not railway. Sila airways. Yeah. So please, if you like to invest in it, by all means, do it. And some applications also can produce of what known as 3D models here. Okay, three-dimensional models. Here is the city of New York. Okay, it can scan the entire area in one go and produce like this. Okay, an area like this, where it can give you the information of building heights, for example. Okay, let's say you wanted to do some taxing. Okay, tax, collect some tax. Sorry. Then you need to segregate between high-rise buildings with low buildings, high-rise buildings and low buildings. Okay, now if you want to select, let's say, buildings that is higher than 80 meters tall, for example. Okay, you do not need to select one by one, of course. You can simply ask GIS software to identify any buildings, any structures that is higher than 80 meters, for example, and it will highlight it for you like this, the red colors immediately. Okay, the red colors building, let's say I just give you an example. Okay, and then it will highlight you instantly which buildings that is higher than 80 meters, and then you can impose some new tax law, for example. Now, next, GIS, other than just to view imagery, okay, whether you use satellite, whether you use drones, or you wanted to create 3D models, GIS also can create maps like this one. Okay, the best things about maps is that it can show you something that are invisible for you. The key point here is, of course, invisible. Let's say temperature. Temperature is invisible. If you look at a desert, if you look at a desert in Africa, you will see and you will guess, oh, the temperature there must be around 60 degrees Celsius. I don't know. Okay. But if you look at another desert in China, you will say, wow, that's the same 60 degrees Celsius. But no, desert in China is much cooler. Similarly, desert in some northern part of Saudi Arabia, it is actually cold there. Yeah, there are no trees, they are just deserts, but it is not hot. So temperature basically are invisible for you. Okay. Other than that, other examples than that is this one. Okay, they are producing maps to search for people that has Irish lineage. Okay, so they map it like this. Okay, by percentage. So the darker the area, that means the Irish roots people. Okay, the Irish lineage people are densely populated, okay, in that particular area. So they can look for it. They can perhaps celebrate what is that celebration? The tiny guy with a green hat. I forgot about it. No. Right. Anyway, it can give you some invisible information. You can map demography map, okay? Um, uh, Throughout Kuala Lumpur, for example. Yeah, Kuala Lumpur is a rich city, but do the people there live there rich? That's a question. Do people live there is actually rich, or they are just living in an expensive city of Kuala Lumpur? That is something invisible. You cannot clearly see the distribution of such people. Okay, so it can create map. It can also conduct analysis. GIS can also conduct analysis, simple analysis such as the editing of geometry. As you can see here, they are clipping this green area out of the entire area shown here. Okay, they can also do some spatial statistics. They can analyze based on values, any values. Okay, next, they can do buffer tools for air pollution, for example. Okay, for water pollution, anything that is propagating, it can you can use buffer tools. Now, let's understand the maps and the data. Okay. Here, if you take a look at this map, what can actually be extracted out? What can be extracted out? You can extract, for example, buildings. Over here, you can extract rivers. You can extract roads. But these are something that is obvious. How about something that is not obvious? So let's take a look. You can extract point of interest, for example, over here, this MIT museum. So other than that, you can also extract any point of interest in this area. You can make it as a single layers, the theme data. You can also extract this street network, the entire street network of this area, just a single layer of street without trees, without buildings, without rivers, just street. Okay, or bodies of water, or parks, anything. Even the buildings can be also extracted as a single layer. So after this, if you want to look at data, you need to look it in a way that it can be extracted by layers. If you process the raw data, it can give you millions of words to explain. Not just a single image can explain 1,000 words. No, millions now. Okay, because there are a lot of things that we can analyze from a single map. The problem is usually whether you have a supporting data or not. You can do millions of research out of a single map, but the usual problem will be whether you have something to support your results or not, or you just short sendiri. Okay. Right. Next is the maps and data. Okay, spatial data types. Let's take a look at it. Spatial data types comprises of basically two types. Okay, there are vectors and another one is raster. These two types of data can explain the entire features on Earth. Everything, the entire features on Earth can be explained based on these two types of data. Okay, as long as it has coordinates. When it has coordinates, it means it is part of spatial data. So what are the differences between vector and raster? Vectors is the type of data that you can easily see based on the representation, like this one. It is just a few points comprises from this A letter. Just a few points, it can produce an A letter like this. Compared to raster, it comprises of hundreds of pixels. Okay, it is in the form of pixels. So raster means pixels, vectors means coordinated points. Okay, you can look at vector easily if you are familiar with AutoCAD. Whether you zoom in how many times, it still shows you a single line that is high definition, as you can see. It is unlike raster. If you take a good photos using your good high resolution smartphone camera, okay, but if you zoom in big enough, you can still see a blurry image. The blurry image is because of the pixels, okay, pixels effect. But we need to use both of these data, okay, because vectors are more suitable for something that is contain a lot of uh, input data, manually input data. As compared to raster, it is in a form of continuous surface. It is more on something that you roughly capture from of an area. For example, you take your camera, you capture the uh, image of your mother, okay, then it is actually in form of continuous surface of pixels, right? Okay, now first data types, let's take a look at the vector. Okay, vector, there are three types of vector data. First is point data, lines data, polygons data. All these three types are vector data. Okay, point. Point is a single dot here, okay, where it holds at least the coordinates of x and y. For example, lines is when these dots are connected. At least there are 2 points in order to form a single line. And of course, if when you make it as an enclosed polygon, okay, enclosed lines, it can form a polygon. If you connect lines and form something that is closed, it will form a polygon. And of course, most of the times, every analysis comprises of these three types of vector combined together like this, okay, like this on the right hand side. Now, Vector has a front end geometry. Okay. In this example, the geometry represents state polygons. When we talk about front end, it is something that is being shown to you. Okay. But vector also has some manually input data, which is known as the back-end database. Back-end database. For example, these locations. Okay. These locations can be displayed to you as it is, like this map. This is known as the front end. You cannot explain much, except perhaps you can explain the size of the states. Okay, the size of these states is bigger than this. The size of this is bigger than this, just like so. Okay, nothing much. But from the back end database, where it has informations of attribute. Okay, we call the informations as attribute. These attributes can explain much deeper than just the image. It can give you population per square mile, means it can give you the density of population that live there in that particular state. Okay, it can give you the area in meter square, can give you anything that is available or something that you include manually into the data. Okay. For example, the kilometers of roads in state A, for example. How many kilometers of road available in Nibong Tebal? Okay, that's a tough question. But through vector mapping, it can give you the answer. Okay, vector, I mean the back-end database can give you the answer. Now, here is just the example. The data can be qualitative variable, means something that is not numerical. Okay, anything that is just words. Okay, that can be the data, and it also can be a quantitative, something that is numerical, like this one, numbers. Right. If you produce a mind map, it actually can help you so much. Okay, because there are many rooted, as you can say, link from one point to another. So if you can produce a mind map, you can see and understand GIS much better. Next is the file formats. Okay, vectors has usually comprises of multiple files, multiple types of files. Okay, like this one. Just to produce a shapefile, it requires 5 different types of files. Okay, but when it is combined together, it produces a shapefile. It is not like the image that you capture in your phone. It is just a single file, whether it is JPEG or PNG files, okay, or bitmap. So it differs. It differs with vector. For a single file, it comprises a lot more, as you can see, children files. Now, second types of data types, of course, is the raster. Okay, raster includes aerial photograph, whether it is from the commercial aircraft or from drones. It can also be digital elevation models, heights like this one, and it can be from scan maps like this one. The maps that you obtain from any library, okay, from any agencies, government agencies, usually in the form of map. You can purchase the map and you can scan the map, right? Okay. Now this is raster. It comprises of pixels. After pixels, after pixels, it connects and forms surfaces. Now, raster raster data have a front end cell matrix. Similarly, you can look at this entire map. This is the front end. Okay. Whether or not it has back end, of course it has. The front end cell matrix here contains a lot of informations. Okay. Sometimes it is explained in terms of colors, and sometimes it explained in terms of gray value like this. The whitest area means it is on a higher ground. The darker area means a much lower ground. So this area is actually containing a mountain range, as you can see here, because the white color are connecting like a mountain, okay, the mountain range. Next is the back-end database. Okay. Of course, we still call it as attribute table, but it is not something that you manually insert. Okay, it is not something that manually insert. It is more like an image that you captured. Whatever you have in front of you, that's it. That will be the attribute. Okay, usually it will be in a form of counts. Okay, let's say the value number one. The value number one here represents yellow color, bright yellow color. So how many yellow color pixels are there? Here, 1,399 units. Okay, 1,399 units of pixel. So this is how a raster backend database is explained. Okay, it is not manually input. Usually, it will not be manually input. Okay. Now, raster file formats also has different of file extensions, but usually it will be a single data like this. I mean, a single file format like this. Whether it is TIFF, usually it will be TIFF because TIFF can stores coordinates. Okay, it can be in the form of ASCII, like a text file. It can be in the form of IMG image or JPEG, a compressed image. Okay, but it is singular. It is not integrated and forming a single file. No, like vector, where there are 5 children files. In order to explain a single shape file. I know this might be a lot. This may be a lot for you, but this class is recorded, so you can watch it again if you wanted to. Right. Now, the tabular data types. Okay. Other than spatial data in the form of map, like vector and raster, it can also be in the form of table. Okay, as long as it has the information of coordinates. Again, when we talk about spatial data, it must have some information of position. Now, yeah, It can be a shared unit identifier. I mean, it can use a shared unit unique identifier like the unique ID. Okay, from one table to another can be connected using a unique ID. For example, the your IC number, okay, IC card number. So your IC card number can be connected with your uh, Touch and Go e-wallet account. For example, it can be connected with your WeChat account. Okay, because of there are informations of unique identifier. Okay, unique ID. Next, it must has a geocoding. Whether the coordinates in the form of latitude or longitude, or it gives you addresses. Okay, if it gives you addresses, then we can look for the particular address, and identify the uh, uh, the position. Okay, yeah. So that is table data, the third data types. Okay, usually the file formats of the table data is in Excel. This is the latest Excel XLSX. Okay, recently I found again that it cannot be used in quantum GIS. I actually confused with ArcGIS. That means ArcGIS can use this format XLSX, Excel files extension. It can also be in comma delimited, you can say. The CSV files, okay, it comprises of a lot of information, but be separated just with the comma. Now, of course, it can be in the form of database too, DBF. Now, okay, let's take a look at the geodatabase. There are basic database. There are also of what known as geodatabase. Geodatabase here comprises of a lot of spatial data that is connected with one another. Okay, if you want to look some particular data from another layer, by using geodatabase, it can search for you the information. It can extract for you. Okay, it is not like a typical database which doesn't has the information in terms of position. There are a lot more data formats, of course. Okay, because peoples are very generous. The experts have which has a lot of free times, but a lot of ideas. It gives you a lot of things for free. Okay, usually. So, for example, GIS can import and convert data produced in other formats such as the KML or KMZ files from Google Earth, AutoCAD files, DWG, DSF, scientific data, LiDAR data, LAS, okay, GPS units data, GPX. If you use Garmin, and then you mark any points, it will be in the form of GPX here. GeoJSON also, an extension of JSON. GIS software can export many formats too. For example, the Adobe Illustrator formats, .ai if I'm not mistaken, KML formats for Google Earth, AutoCAD, CAD, TIFF, in the form of image, JPEG. Okay, these are the fundamental of GIS software. Okay, can give you a lot of other formats to work with. Next is a common associated workflows. Okay, there are data from satellite remote sensing from the satellite. There are 3D modeling and photogrammetry from drone or aircraft, okay, which captures the image from the sky. There are statistical analysis. There are also visual design using Illustrator, for example. Okay, uh, these are common associated with the GIS, where the 3D modeling and photogrammetry or the satellite remote sensing usually can be processed as rasters or vectors. Okay, and the raw imagery, let's say the area of Nibong Tebal, the area of USM, can be in the form of the base maps. Okay, later we will touch on what is base map. Next, it can process imagery as rasters or models like the DEMs, which can produce 3D data, okay, 3D representation. Next is the attribute tables for running analysis, especially the statistical analysis. And it can be also, the final one, can improve the maps so that it looks easy to your eye, highlighted the uh, the biggest information that you wanted. Okay, so this is the functions of visual design. Okay, sometimes you can enhance it using Illustrator. The map, you can enhance it using Illustrator, yeah, to make it more beautiful. If you want to produce a poster presentation for your FYP, you can use Illustrator too. Right. Let's take a look at the maps and data by its characteristics. So the characteristics of map, usually to simplify the maps. Okay. First thing first is this generalization. Okay. To simplify the maps, the entire maps. If you capture a map from, let's say, if you bought a map from tourism, Ministry of Tourism, the map will give you an information of uh, point of interest. It will give you the information of road and shopping mall, for example, something that is mostly used by the tourists. Okay, it will not give you let's say, where are the ATMs. It will not give you the information, let's say, where is the pet shop, nearby pet shop, because it is not that crucial for the tourists. Okay, the tourists usually will change the money, okay, and bring a lot of cash rather than having to go to the ATM usually for the locals. Okay, but for money exchange, perhaps yes. That is what known as generalization. To generalize the map in order that in order to what we call this to focus on the objective of that particular map. All right, I've talked too much. Next is the abstraction. Abstraction is something that if you uh, see the map for just 5 seconds, whether you can extract the information from the map or not. Okay, that will be the abstraction. It is not generalization, because abstraction is something that is make it easier for you to identify anything. Let's say for this example, shows the airport. Okay, it shows the airport. So from A, B, C, and D, if you can go through the huge maps, okay, and you wanted to look for airport, I believe you will see the position of, or the location of airport much easier with option B, because option B literally put the icon of an aircraft. But abstraction also is important for certain types of targeted users. For example, if you are a pilot, you might want D instead of B. Okay, you might want it to look at D, donkey, rather than B, baboon. Right? That is the objective of the, it depends on the objective of the map. But usually people will choose B. Now, the next characteristics is the spatial resolution. Okay. Here, I provide you some images. Okay. If you take a look at here, on the left image is where you zoom in. You zoom in to the closest scale as possible, and then you will see these white roads. These white roads, white colored road, is the inner road. Okay, whereas the yellow one is the main highway. The main highway that is connected between states, for example. That's why if you zoom out, you will be given only the yellow road, which represents the major road that is connecting between states, or between area, region, for example. Okay, that's why on the right hand side image, when you zoom out, it will show you only the yellow main road. That is the spatial resolution or scale. Okay, you need to know what is supposed to be highlighted. Okay, if you zoom out like this, what should be highlighted? If you zoom in like this, what should be highlighted? Okay, that is a spatial resolution. Now, the temporal resolution. The next characteristics of what I call this, of maps is temporal resolution. Temporal resolution here, if you take a look at the area of USM, okay, in 1985, the satellite imagery shows no sort of development occurring over here. No development in 1985. It's just what we call this, palm oil plantation, palm plantation. Okay. Now, if we go through the time, okay, you can see the developments by stages. But I cut short simply jump to 2026, there are a lot of development already taken place in this area. Okay, this is what known as temporal resolution. It deals with the progressing of time. Now, of course, you can obtain the satellite imagery open sources from back to 1980s, 1970s data. Okay, you can have it, and then you can do analysis using temporal resolution technique. Okay, now searching for special data here, look in general GIS data repositories. Okay, there are a lot websites that provide to you the data, but most of them are not downloadable. Okay, the data are not downloadable. Only few that give you the ability to download the data. Now, let's jump this. Some of the repositories and websites are OpenStreetMap. OpenStreetMap gives you high detail vector data for free. But the question is only relies on the accuracy, because OpenStreetMaps is crowdsourcing data. So not every individuals that donated the data has the understandings of GIS. That's why the downside of OpenStreetMap is that it requires you to apply some accuracy assessment, okay, before you use the data. Now, next is the USGS Earth Explorer. It provides you free to download satellite imageries, but with a limited resolution. Okay, it provides you 30 meters resolution. Although USGS themselves has a much higher and much more precise data. Okay, perhaps they has actually 1 meter resolution data, but they keep it for themselves, of course. Okay, they give you the one that is free. But the best thing about USGS Earth Explorer here is that it gives you as latest as last 1 week. Okay, it can give you weekly data, but it doesn't, of course. It just give you at an interval of some interval every 2 months. Some give you as interval every 4 months for a single new image. Next is the Earth Now School. It provides you with live wind data. It's very interesting, but it is not downloadable. The data is not downloadable. The GPS also provide you with the live information regarding water level and flood. Okay, for those who wanted to study flood, you can take a look at GPS websites. Give you interactive map. Okay, that give you this information, but you need to extract it yourself. Next is the minerals resources government agencies. Okay, it provide you free downloadable geological data. And the last one is the iPlan Malaysia, which give you free access to land use map. All of this from Malaysia and the other open source software, websites, does not give you downloadable data, most of it. Okay, but it will be a good data if you can simply extract it using the back end algorithm. Of course, there is always a way, okay, if you study deep enough. Next, on maps and data is the metadata. Metadata is the information of the data of the data. Okay, so these are example of the data of data. How to explain the data, whether it has coordinates data or not. If there is a coordinates data, what are the types of projections? What are the types of coordinates reference system that were used uh, in the data? That is what known as metadata. Okay, there are metadata examples over here, but I'm not going to click it. Let's jump to making great maps. Okay, data visualization principles. Now, a great map is a map that contains the sciences, of course, okay, for you to display any research data of findings or the results. Okay, that is the science. But it also has the second part, which is the art. Okay, what color is the best colors? Like this map, the Google, uh, the Google map has one of the best color combinations here. Why? Because it helps you to understand the types of road, the types of building, the types of land use, without making your eye goes tired. You can look at the map for hours without having a sleepy eye. That is the definition of the aesthetic element of a map. Okay, and the study of making this is known as cartography. Cartography. Okay, it teaches you what color combinations for your map. Okay, maps are always simplification of reality, which makes them helpful when making decisions or explaining patterns. Okay. Next, maps are designed by people who have intentions, so we have to create them responsibly. What are the intentions? The intentions is to help, usually, to help the tourists to find some space, some area, some point of interest. Okay, to help the road users to determine the types of roads much easier. That is cartography. Okay, there is an example here, quite deep example. I'm not going to touch it. So the three questions: who wants the map? Whether it is experts, you need to make it into great detail, or whether it is students that needs the map, you can make it as contextual based on the students uh, uh, based on the students, what we call this the terms, uh, anything that the students wanted. Okay, you can make it in context with the students needs. Okay, next is the community. Usually it must be interactive, because community, some of them read a lot, so they are familiar with words. Some of them are not. Okay, so they wanted something that interactive. They just click in one button, then all the informations can be displayed easily. Okay, where will it be seen? If on the side of the road, on a billboard, then the letters, the fonts need to be clear. Do not use cursive fonts, which is much harder for the driver on the side of the road to read it. Example, okay, that will be the example. The example given last 2 weeks to your friends are the wedding invitation card. The wedding invitation card need to be simplified, generalized, in order that the visitors, okay, the one who wanted to attend the weddings, can find the wedding hall or the wedding location much easier. Okay, so you need to understand this. Where will it be seen? Whether the person who has the maps can look at it for hours, or he can only look at it for split seconds. So you need to understand that too. What is the purpose? What is the purpose? The purpose, whether it is through time, time series like the temporal analysis, or whether it shows changes over time, can answers through change detection method. Okay, it can combine multiple variables into an index to pick best or worst, such as the sustainability map, the risk map, vulnerability map, okay, something like that. Let's say you are going for a hiking, and suddenly there is a heavy rain downfall. Okay, so which area is the riskiest, the highest risk, and which area is the least risk for the hikers, for you who wanted to go for hiking? Okay, that is something that shows you the best and the worst. Okay. The map design process starts with the assembling the data from multiple sources. Okay, any sources that you can obtain, you need to collect it. Of course, back in my days, I need to purchase maps. I need to go to some museums to obtain maps. But nowadays, people go for digital. Okay, so you need to collect from multiple sources, whether on websites A, websites B, websites, any other website. Okay, but usually nowadays it will be as simple as going to the website. Now, next, choose the data, analyze, and symbolize it with a proper symbolization. Okay, and then lastly, insert the title, the legend, which shows the information of this circle over here, the north arrow for the maps, the scale bar, and labels like this. This will be the final looks of the map. I'm not sure what is this. America's 50 largest cities. Here. This is the title, but it is not in a good form. Title must be in center and must be much bigger than this. So do not produce something like this. No, you can do better. There are a lot of vector symbolization. For example, the aircraft I showed to you here. I need to scroll, it's quite up here like this. whether in the form of aircraft, whether in the form of other things. Let's say you want to study the bird migrations, okay, you can put bird as the symbol. But all of that, there are variables. Okay, small size represent lower number of birds, for example. Large means there are a lot of, there are massive community of birds. Whether or not I use this the correct terms or not, I'm not sure. But the sizes give you an impression of the quantity. Okay, the pattern, the the um the higher the shades, okay, or the darker the shades of a pattern means it is greater in numbers. The darker, okay, the saturated, it means it goes from lower to much higher in counts or in values. Okay, there are also graphic element as I mentioned to you just now. The picture of the aircraft. Okay, yeah. Now raster symbolizations. Um, there are few ways to uh, represent a raster. It can be in the form of stretching, you know, you can stretch, you can clip, you can expand the image. Nowadays there are a function of upscaling an image. Okay, that is uh, the raster, part of raster symbolization. Okay, it can be stretched, it can be in a form of discrete, it can be in a form of classification into classes. This is very important for the water quality people. For those who do water quality, you need to classify based on the classes of pollutions. Okay, that was provided by the Department of Environment, of course. Next are the unit values, and the last one will be the vector field or something like this, where it shows you directions, whether directions of wind, directions of water flow, can give you this information. Okay, this falls under raster symbolization. The color schemes, the color schemes can be in the form of qualitative here by categories, where the color is discrete from one another. Okay, it does not have some sort of patterns, whereas the quantitative in the form of numbers, it can be in sequential like this from lighter to darker, and it can also be diverging like a pH level. Okay, whether it is acidic or alkaline. Okay, the normal will be in the center. This is diverging for those who do the water quality maps. Okay, here are the examples. Okay, the color that are discrete, it is not this sequential. This is the sequential where it gives you the intensity of some information. Like this one, it wanted to show you the internet users, okay, per 100 peoples. The darker the area means the higher the numbers per 100 people, okay, that uses internet. Diverging, like I mentioned just now, okay, it can be both sides. Okay, intensity increase whether to the left or and also to the right, but the center will be normal. Okay, commonly used map type is known as chloropleth map. Okay, As for these examples, is spending per student by school district. So when it said by school district means it has boundaries, district boundaries, okay? And it also has the information of the spending per student. Perhaps they have conducted some sort of questionnaire or interview to the students. Okay, that's why they obtain these informations here. Okay. These use different shadings and coloring to display the quantity or value in defined areas. Next, the chloropleth maps choices are based on two methods. Okay, first, of course, is the number of classes. Second is the classification method. Then number of classes here can increase up to 50 classes. But whether or not, if you increase the number of classes, um, you need to be able to explain the differences between one class to another. That's why the Department of Environment produces only up to 5 classes for water quality to explain water quality. Class 1, class 2, until, if I'm not mistaken, class 5, if not class 4. Only few classes were to be used as a regulations. Sorry, again, I talk too much. Now, second, the classification methods. Data classification is how data is arranged into separate classes. It can be equal intervals. Okay, let's say there are 100 peoples and you want to divide it into 5. Means every classes has contain 20 people, 20 people, 20 people, 20 people. But next is the quantile. Okay, equal count. I forgot quantile. How quantile works? But I forgot. But next is the natural breaks, where it looks at the data. The GIS looks at the data and uh, based on the data, it creates automatically the breaking class. Okay, between class 1 to class 2 to class 3 and until class number 5, for example. Okay. Next is the defined intervals is defined by you, of course. Okay. Whether the starting of out of 100, the startings will be 0 to 10, and suddenly 11 to 30, and 31 to 80, for example. You define the intervals your own. A. Yeah, I'm not going to stop. I'm going to just go straight until 10 o'clock. I hope so. Right. Next is the classification methods. Okay. Oh, yeah. Just now I explained to you about this. Yeah, the quantile is classes that have equal counts. Classes that have equal counts. Let's say there are 5 classes. There are hundreds peoples, and some peoples, a number of peoples holds 1 ringgit. Okay, other peoples holds 5 ringgits. The 5 ringgit notes. Okay, some of them holds 10 ringgit notes. So these are quantile. Whether the number is equal or not is a different story. let's say those who have 1 ringgit notes is 35. 35 of them has 1 ringgit notes. Okay, and then suddenly 15 of them have 5 ringgit notes. And then 30 of them has 10 ringgit notes. So it based on the equal counts of a certain criteria. As I mentioned just now, is the ringgit notes. So that is by quantile. Right? You can see the mapping also different. So it depends on how you explain your classes. Okay, the easiest, usually the easiest for you guys, the FYP students, just referring to regulations. You go to the regulations book and you can look for uh, the given classes. All right. Next is the mapping layout design, mapping layout design. So there is actually rules for this. Okay, but basically you need to have a title, legend, scale bar, labels. These are the most common. Okay, what are title? Of course, the title is the aim of the map. Okay, to show the distributions of obesity people. Okay, the legend will be the density of obesity people by cities. Okay, the scale bar is the sizes of the map to the distance on the ground, the actual distance on the ground. Labels is where, for example, you are relating the obesity density of an area, of multiple areas, and then you compare it with the numbers of fast food franchise in that particular area. So the more franchise, fast food franchise, the higher the density of obesity people. For example, just give you an example. Okay. Yeah, that explains this. Next. The goal is to design the map layout to support your design questions. Who wants the map? Again, I've mentioned this before. Where will it be seen? What is the purpose of the map? Okay, right. If you arrange the map carefully, okay, it will be easier for people to understand it, the entire map. It is like a story. Okay, from top you will see the title. Okay, the user have in mind, okay, now I'm looking at a map with this title, and then you look at they will look at the skill bar, or they will know what are the extent of that particular map, something like that. Okay, right. Of course there are tips here. Inset or locator maps are often placed in the top or bottom corners, like this. Okay, here, locator map. The main map often placed in the center, here, placed in the center, because it is much easier for the people to look for it. Okay, legend is stuck into the main map for easy comparison with the data. So legend must be right on the side, if not on inside the image itself. Okay, legend will help the people to look at it and have some definition for the colors. For example, here it shows colors. So for those who look at this map, they wanted to refer to the legend much quickly and easily. So that's why this legend must be big enough and must be close enough to the image that wanted to be shown. Okay, so that it can refer quickly. Sometimes if for a bad map, for example, okay, the map itself is on the farthest right hand side, while the legend is the farthest apart to the left hand side. It will be much tedious for the uh, people to look at the map. Okay. Now, I would like to introduce to you the next part of this theoretical lecture, which is known as spatial analysis. Okay. Here are the same example I given to you earlier. This is part of the spatial analysis, which is the clip tool. Okay, the clip tool to extract part of the data that is wanted. Okay, to extract it from the raw data. Next is the analyze values. It can be vectors, it can be rasters to analyze the values and form something like this. Okay, this one is spatial statistics. Next is the buffer tool. Again, it analyzes something that is propagating easily. Let's say noise pollution, air pollution, and so on. It can propagate much easily. So sometimes people are using buffer tools to identify the affected area. Next is specialized tools are used to quantify patterns and relationships in your data. For example, the spatial statistics here, okay, where it relates one another with other types of data that you have, okay, and that produces something like this, the hotspot. Next is the interpolations, which give you the information of one place to another, the in between. Okay, the interpolation usually will give you the data that is not being measured. The area is not measured yet the data can be obtained with the help of interpolations. Next is the network analysis. If you wanted to study the if you wanted to study traffic data, if you wanted to study the uh, the shortest path, sorry, the word doesn't come. If you want to study the shortest path between point A to point B, usually you will use Google Map, you will use Waze, okay. You can you are actually applying network analysis. You find the shortest distance. Okay. Next is the suitability analysis. This, for example, very useful for to develop a plantation area, for example. Okay, you want to plant a banana tree. So banana tree requires a lot of water, a lot of this, a lot of that, in what types of soil. Okay, all that criteria are compiled, and then it can produce of what known as suitability analysis. You can find the most suitable area for the uh, banana plantation. Okay. Now, multiple tools are often used together, like this one. Okay, this they want to find. Is there any information here? No. They want to find the best locations for, let's say, a new school. A new school. So now the base criteria will be the land use, the elevations, the recreational sites, and the current schools. Okay, and the derived data will be slopes. From elevation, it can produce slopes. From recreational sites, it can produce distances between one to another. Schools, it can also produce distances, okay, that relates from one school to another schools. Now, the land use can be transformed into a much more generalized data that is required in the research. Okay, the slope data can also become the it can be modified in order to be able to see much clearer which part is the lowest area and which part is the highest area. Okay, like this. And then distances, it can, produce something like this. Okay, this one is actually, it relates from one point to another and it produces, um, I forgot what are the terms. Okay, but it produces something like this. It is like the density mapping. Okay, and they overlay the entire data and will become like this, and they now find the best location for the new schools. For example, map projections. Why do we care about them? Projections is one of the key and most important informations that you need to have. Okay, for example, here with a different projections, with a different coordinate systems, although it doesn't seem very much here, the differences, but it actually can go up to 50 meters distance. Okay, and you do not want this from happening, because if it is occurred without you realizing it, it will cost the projects millions of ringgits just to repair the mistakes. That's why coordinate systems is crucial. You need to make sure that you understand coordinate systems. Which coordinate system for Malaysia, for example, okay? You cannot just receive any data from someone else, from any agencies, assuming all of them has the same coordinate system. No, please don't make that mistake. Analysis tools that involve shape, area, directions, form, or distance calculations require data to be in a suitable projected coordinate systems. Of course, these Earth are huge. There are a lot of coordinate projections that are available. You must identify which one is the best to be used for that particular area. Okay. For Malaysia, we uses transverse Mercator. Transverse Mercator. Okay. Here, this one. We do not use other than that because it doesn't suit the geographical formation of Malaysia. So the differences, as you can see, is like this. It's huge. if you wanted to work with international, if you wanted to work with international company, GIS company, okay, you need to make sure what types of projected coordinate system that they are using. If not, the data will be like this. Data will be like this. Which one is the correct one? Is the right hand side or the left hand side? You cannot assume. You need to support your answer. Okay, right. Map projections, what are they? I repeatedly say projections is important, coordinates is important. That will represent spatial data and so on. Okay, now the true form of the Earth is like this. Okay, it is more like the ostrich egg actually, because the Earth is spinning, and due to the centrifugal force of the entire Earth, the equator is much bulkier, okay, than the pole. Next is the geoid. Geoid is a representation of Earth in mathematical form, but based on the magnetic measurement of that particular area. Okay, next is the ellipsoid. The ellipsoid here is one of the most perfect mathematical representation, but it has a lot of faulty too. Okay, because the Earth cannot be assumed. Earth are active. Even every continent is actually moving. If I'm not mistaken, the continents of the nearby the Hawaii island moves 5 centimeters per year. That's a lot. Okay, so ellipsoid representation datum is the best that we have currently, not this one, the circle one, because the Earth is like an ostrich egg because of the spinning effect, the centrifugal effect. Okay, therefore, the perfectly sphere Earth is actually not true. Okay, it is not true. Now, how the projections are being made? Okay, so imagine an orange as the Earth, and you want to be able to peel it in such a way as to lay the peel flat on the wall. How? It is not possible. Not possible. That's why they apply of what known as projection. Imagine that there is a flashlight over here, torchlight over here. It pointed to this area, and it further projected this area onto the flat wall. Okay, we want to flatten it. Of course, when you flatten it, it will not be the actual representative of the Earth, of the countries. Alhamdulillah. Next, a projected coordinate system consists of geographic coordinate system, projection algorithm, linear unit, parameters that centers the system on a certain locations. All of this that comprise a single projected coordinate system. You need to understand this, okay? You need to understand this, especially if you work overseas. You need to know what is the projected coordinate system being used in that particular place. Okay, all right. Now, there are many different types of projections, of course. Each have certain strengths and limitations in the following types of distortions. It can be distorted in the shape, in terms of shape. It can be distorted in terms of area, in terms of distances from one place to another, in terms of directions. It will not be perfect. Nobody able to produce an algorithm that is perfectly match the Earth. No, so far. You might be the first one if you try. Okay? Now, coordinate systems characteristics. There are two types of coordinate systems. First is the geographic coordinate systems. The second one is the projected coordinate system. Geographic is on 3D spherical. The units is degrees, latitude and longitude degrees, and the lines, angles, and areas change with distance away from equator. The best representation usually will be at the area of equator, but due to the spherical in shape, it shape like, okay, it pointed to a single direction on the north, pointed a single direction on the south. That's why the area will not be or the shape will not be perfect when it close to the pole. It will be much more perfect when it's closer to the equator. How about projection? Projected. Projected is not 3D, instead it is a 2D flat surface. Okay, it can be measured using meters, kilometers, miles, and feet because of the linear formation of the projected map. Lengths, angles, and areas are constant. Areas constant across the two dimensions. Okay, how to say it? It actually it holds the best lengths, angles, and areas of the country. Okay, that's why there are a lot of types of projections, and these types of projections actually helps to represent the country as a higher accuracy as possible. Okay, therefore the reality always started from the Earth, and it is converted into geographic coordinate system like this, and it is projected to a projected coordinate system like this. So these are the sequence of the coordinate systems. Now, there are commonly accounted systems. Okay, WGS 1984 over here. Okay, do not look at the other. If you are working in US, you will need to use this one, North American datum. But the highest usage usage types of coordinate system is this one, WGS, World Geodetic System, of developed in 1984. Okay. The projected coordinate system here can also explain in terms of zone numbers. Okay, for Malaysia, it is 47 north for Peninsular Malaysia, 48 north for Sabah and Sarawak. Let's take a look. 47. If we zoom to the line, if we go along the line, it will fall on Peninsular Malaysia, while the Sabah and Sarawak is 48 and 49. Okay, 49. So Peninsula is 47, Sabah Sarawak is 49. These are the cuttings. Okay, of projected coordinate system. Okay, similar to the previous one. Tips on selecting a projected coordinate system. This is very useful if you are dealing with international company. Whether you want to preserve the area, whether you want to preserve the shape or directions or distances, you need to choose. Okay, but usually if you preserve the area, you will not preserve the shape and the other. Okay, if you preserve the directions, it will not preserve the distance. Just like that. That's why nobody be able to to develop an algorithm that is perfectly represented the reality of the Earth. No, not yet. Okay. Tips on selecting a projected coordinate system is, of course, based on the size, based on the region. Okay. This one is much more deeper, so I'm not going to touch on this. Okay. How do you know the coordinate system of your data? Of course, you can know the coordinate system based on the metadata of the data itself. It should provide you these informations, okay? What types of coordinate system being used. And if you wanted to look at a much more confident level, you can take a look at the integrated data from the working folders. If there are PRJ here, means this represents the projection. Okay, you can take a look at this, whether I mean for the types of projections that being used. Okay, here for the quantum, you can take a look at the layers properties, and we'll tell you at the CRS category, CRS coordinate reference system. It will give you the information. Okay, now from the metadata also you can take a look at it, not just properties from the website, I mean from the desktop software. Okay, processing tools, there are a lot of processing tools available. Okay, here it shows the geoprocessing, it shows the buffer tools, a lot more, of course, a lot more. There are batch process tools that if you have 50 data where you wanted to process all 50 data with the same technique, you can use batch tools. Okay, it will process all at once. But if you put errors, then yeah, you need to fill it in again. Right. If we compare between our GIS and quantum GIS, this I already explained, isn't it? Okay. If you compare the ArcGIS tools, it has a lot. Okay. The 3D analyst tools, they are like what, 15, 10 tools. Analysis tools, there are 20 tools. Yeah, a lot more from here. Okay. But the differences from quantum GIS is that ArcGIS is secure. It has its own experts and it cannot be changed because it is not an open source. It is expensive. Okay. This is widely used. The 3D analyst, business analyst, geostatistical, image, network, spatial analysis, and so on. There are also maritime for defense mapping, a lot more. Okay. This is from our GIS Pro extensions. How about the quantum GIS? Actually, it's about the same. Okay, but it comprises into categories. First, quantum GIS. Another one, is the grass. Okay, quantum GIS is much more easier to be used, but if you want to go deeper into the research, you can go for grass. And here are some of the vector analysis tools, geoprocessing tools, geometry tools. There are a lot. All of these are vector. How about raster? Raster also got a lot of tools here. We will learn some of them, but of course not entire tools will be used. Okay, and a lot more. There are plugin repositories. You can download anything that was made by experts that donated the plugins. Here are some vector analysis. You can do buffer. Yes, you can create and edit the features like this one. You can clip the vectors into a much smaller. There are a lot of road networks here. You can clip based on the area that you wanted to study. Okay. Surface analysis, you can conduct interpolations, widely used. We will learn about these interpolations. There are extract. Of course, extract is similar to the vector extract. There are also raster extract. Contour from the DEM, DTM, or DSM. Anything that is 3D data models, you can produce a contour lines like this. Okay. You can produce slope for 3D mapping. Zonal statistics, the statistical analysis by zone, there are a lot more. Okay, they are used to analyze patterns, analyze terrains, to generalize sophisticated or complex maps, manage data, summarize the data, proximity. There are spatial statistics too. Okay, spatial autocorrelations. This here is more on if you wanted to study on master level or PhD level. Okay. Yeah. K nearest neighbor, polygon contiguity. This one are now we are going a much deeper, much higher level. Okay. I will not touch on this for our practicals. Only the few examples. The much easier tools that will be used. Okay. Distance and network analysis, to measure distances from one place to another, whether it is the shortest distance, whether it is shortest time, whether it is the least expenses, least cost, everything. Yeah, a lot. Routing service also use network analysis, like your GrabFood, your Food Panda, anything. Routing service. Service areas, which way a cluster of industries that is located. Okay, closest facilities, cost metrics. This one uses raster. Vehicle routing problems. Just like my PhD, I did this. Out of many analysis tools, I just focus on this one. This one also can be extracted into 20 different types of VRP, locations, allocations, and so on. So with that, guys, I thank you very much. This is just the theoretical part. Later, I will produce if we do not have times to meet, by physical, face to face. I will conduct a recorded analysis, a recorded what's this? I will conduct a recorded practical sessions. Okay. And then I will send the video to you for you to follow. And if you have any further questions, you can ask me personally. I'll try my best to assist throughout your FYP. If you want my help in great detail, perhaps you can discuss with your supervisors to include me as the co-supervisors. Okay, so that we can discuss into your topics much further. So with that, I thank you so much for your attention. I hope to see you one day for the practical sessions. It will be much easier for face-to-face rather than, you know, through online meeting like this. Yeah, with that, thank you so much. I will give you the recorded these meetings, the recorded uh, uh, videos, of course. So with that, bye. Thank you very much. Yeah, goodbye. See you again.